Dr. Meenal Lerkar welcome you all to this session on bubble sort, which is one of the simplest sorting algorithm. In this video, we are going to learn what bubble sort is, how it works step by step, its implementation, and finally its analysis. Bubble sort is the simple comparison based sorting algorithm. It repeatedly compares the adjacent elements and swaps them if they are in wrong order. After each pass, the largest unsorted element moves or bubbles up to its correct position at the end of the array. It is known as bubble sort because every iteration, the largest element in the given array bubbles up towards the last place or the highest index. Just like the water bubble rises up to the water surface. Now, sorting is done pass by pass. Okay, so after every pass, one more element reaches to its final position, and gradually, unsorted portion becomes smaller, and finally, the complete array becomes sorted one. So, in case of bubble sort, as I told you, it compares the adjacent element. So, in the first pass, see these two adjacent elements are getting compared. As we have to sort it in ascending order, so we have to swap those elements. So one come over here, 5 occupies this position. Now next time these two consecutive elements are getting compared, they also need a swapping, so we will get this output. Now next time these two elements are getting compared, these two adjacent elements are getting compared, swapping is required, so we will get this output. Now next time these two elements are getting compared and there is no swapping required as the elements are already the ordered one. So if you observe, this is the output of the pass one, where we can able to fix the position of the largest element in one pass. So for the next pass, the number of elements that we have to consider for the comparison is reduced to 4. From the 5 it reduced to the 4. Okay, so in every pass the number of elements will get gradually get reduced, and the number of sorted elements gradually gets increased. Okay, so that is why, as we have seen, in one pass we are able to fix the position of the one element. So the total number of passes that we are requiring is always n minus 1. Okay, so if there are 5 elements, so the total number of passes that we will require in order to sort the entire array is 4. Now coming to the next pass, the output of the previous pass, that is 14258, will act as an input to the next pass. So over here, if you see 1 and 4 are getting compared, there is no swapping required. Then next pair of consecutive elements, that is 4 and 2, are getting compared. They are swapped. Okay. Then next time 4 and 5 are getting compared, then there is no need of swapping. So over here, if you observe, in the past two we can able to fix the position of the second last element. Okay, now then in the next pass only three elements are getting compared. So one is getting compared with 2, there is no need to swap. Then 2 is getting compared with 4, there is no need of swap. So now we will stop over here. So here in this pass we have fixed the position of the third largest element in the array. Now during next pass, 1 and 2 they are getting compared, and as there is no swap required, So over here, whatever is the output of this pass, that is the sorted one. So this is how the bubble sort works. This diagram shows the animation of how exactly the bubble sort works. So two pair of consecutive elements are getting compared, and if swap is required, they are getting swapped. So over here 6 and 1, they are getting compared and swap is required, so they are swapped. Next time 6 and 8 are getting compared, and there is no swap. So 8 and 7 are getting compared, swap is needed, they are swapped. Next time 8 and 2, they are getting compared and swap is performed. Next time 8 and 4 are getting compared and swap is performed. So if you observed over here, in this first pass, we can able to fix the position of this element. Okay, element at the last position. Okay. Now in the next pass again, the same process is repeated. Okay. So this is how the uh, bubble sort works. Now we will see the coming to the implementation part. So over here the bubble sort is not returning any value, so return type is void. The name of the function is bubble sort. It is taking two parameters, that is array to be sorted and total number of elements to be sorted. Bubble sort function contains two for loop. This outer for loop is responsible for the number of passes, and as we have seen, in every pass we are able to fix the position of the one element, so the total number of passes will be one less than the number of elements. Okay. Now in the inner pass, we are comparing the consecutive elements, and the total number of elements that we need to compare, that depends on in which pass we are. So always the total number of elements for the comparison is one less than that of the uh, number of one less than the number of passes that we are in. So this j iterates until the total number of elements minus the number of passes that we have already done. Okay. So within this, we are comparing the two consecutive element, that is a of j is getting compared with a of j plus 1, and if it is a of j is greater than that of the j plus 1, we are performing this swap. Okay. So this is how the bubble sort works. So in bubble sort, total n minus 1 number of comparisons are done in the first pass, n minus 2 number of comparisons are done in second pass, and n minus 3 comparisons are done in third pass, and so on. So the total number of comparisons that we have done is the sum of the first n minus 1 numbers, which is nothing but the n into n minus 1 divided by 2. So that is nothing but the n square. So the time complexity in all the three cases is big O of n square, that is best case, average case, as well as the worst case time complexity of the bubble sort is quadratic, that is big O of n square. The logic which we saw will sort an unsorted array. Still, the algorithm is not efficient because the outer loop will keep on executing for n minus 1 passes even if the array gets sorted after the second iteration. So we need optimized version of this algorithm in which we use the flag called swapped. Okay. If no swapping occurs during a complete pass, it means the array is already the sorted one. So in this case, we can terminate the algorithm early instead of performing unnecessary passes. So as we have seen in this optimized version of the bubble sort, we have set the swapped variable to false, and if there is no updation in that swap variable, in the current for loop, this means there the elements are already sorted one. So after coming out of this, we will simply check whether swap variable is updated or not. If it is not updated, this means the elements are already in sorted order. Then we will stop. We won't go for the further passes. In this way, we can reduce the time complexity in best case to the linear one, that is big O of n, by introducing the concept of the swapped flag, where in the worst as well as the average case, the time complexity will remain as a quadratic one. Okay. So to summarize, bubble sort repeatedly compares adjacent elements and swap them when necessary. After every pass, the largest unsorted element reaches its correct position. Its average and worst case time complexity is big O of n square, while optimized bubble sort can achieve big O of n in the best case. Thank you for watching.